So we're looking here at a triangle and the measures are in radians, and we're going to use the sine rule to find this missing angle x. So if I use the sine rule, it will give me sine of x divided by 12 equals sine of 0.5 divided by 8. Now, when I do the calculation, so I'm just going to do that right here on my calculator, I'm going to do 12 times sine 0.5, making sure I'm in radian mode, and divide it by 8. I will get the answer 0.719. Now that is not the angle, but the sine of the angle. So now I'm going to do the inverse sine to get the x. And that gives me 0.803. Now, that means that this angle could be 0.803 radians, but I have to remember that there are two answers between 0 and pi for sine. So I have a second case, which is pi take away 0.803. It's possible, it may not actually work, and we're going to talk about that in just a sec. So I'm going to work out that and find out what the second angle is. So I'm just going to go to pi and I'm going to take away that 0.803, and it gives me 2.34 if I round it up. Now x could be either of these answers. Could be this one, or it could be this one. I will always check the second value to make sure that there is room for it in the triangle. Now what I mean by that is if this is 2.34 and I have the 0.5, that gives me 0.84. So there is room for the third angle. If this was so big, so if my 2.34 and my 0.5 were bigger than pi, then the biggest angle wouldn't work. But because these two angles are less than pi, remember pi equates to 180 degrees, then there is room for a third angle. So at present, both of these work, and this is called the ambiguous case.